Welcome back. Heavy downpours overnight have led to severe flooding in parts of Gauteng. Homes and roads have been submerged, resulting in major infrastructure damage. Power was also affected, leaving many without electricity. While the Highveld is no stranger to rain at this time of year, could climate change be contributing to the severity of weather patterns? Let's unpack this further with Dr. Peter Johnston, a climate scientist at UCT. Dr. Johnston, thank you so much for your time this evening. So often we look at the symptoms of weather events, in other words, the damage caused, to gauge the severity of that weather occurrence. But we know that experts are telling us that a lack of infrastructure maintenance has led to a lot of the flooding and the damage from this last week's storm. So in your opinion as a climate scientist, how extreme have weather patterns in Gauteng been over the past week? And is it a concern?
Hi there. It's a very tricky question because the very first thing that we as climate scientists want to say is that an individual event like this, or even a week like this, cannot be attributed to climate change as such. What we're in now is the summer rainfall season. We're expecting to have rain. The systems are such that the atmosphere is geared towards that. The low pressure systems, the convection, the ITCZ, these are all terms that describe summer rainfall region conditions. And these are all in place to bring summer rainfall to the Highveld, for example. Now, there are two things to consider. One is that, first of all, it was quite dry until late October, in fact, almost middle November. So we were expecting the rain to come at any time. And that was because the system wasn't exactly ready for that. The second thing to consider is it's a La Nina year. Now, the El Nino Southern Oscillation is a system in the Pacific Ocean which influences the rainfall in the Highveld region. And then during a La Nina, and this is the third La Nina in a row, we expect higher than normal rainfall. So we should be expecting the rainfall to be more than in an average year. But that doesn't explain the intensity of the rainfall that's happened in the last week. So it's very difficult for us to explain that, except to say that the systems are such that because it's a summer rainfall region, because it's La Nina, we're expecting to have more rainfall than in a normal year. However, because of climate change, or in fact, let's go back a step, because of the increased temperatures that we've been experiencing, these storms all over the world are becoming more intense. And by that we mean that more rainfall falls in a given episode than is normally accepted or has normally been found in the history. So those are the reasons that give rise to this kind of flooding episode. And for many months, climatologists have been warning that this situation was likely to happen. When you bring in lack of infrastructure development and maintenance, clearly when you do have heavy rainfall, and the system is not ready to deal with that heavy rainfall, one is going to have flooding. And flooding is not an abnormal event. It's just a lot of water gathering together and flowing downstream at once. But if it interrupts or if it intercepts with human activity, for example, settlements and activity in roads and bridges, that is very likely to cause a problem. And this is what we're seeing.
So I want to come to how we cope with that in the future in a minute. But I also want to ask you about Monday's freak hailstorm and why I think perhaps ordinary Joburgers or Praetorians like myself are referring to it as a freak hailstorm is because it seemed to have come out of nowhere, and also because of the size of those hailstones. We saw people holding up chunks of ice the size of a fist. We also saw one of our reporters who was out doing a live crossing injured and the camera knocked over and damaged by that hailstorm, which came down with such force that it's quite hard to expect that to happen on what was quite ordinarily a hot day. Can you explain that phenomenon to us?
Yeah, it's also quite tricky, but let's look at it step by step. Firstly, we must understand that these have happened before. I personally, in 1984, was in a hailstorm in Pretoria where I saw hailstones the size of tennis balls smashing through car windows and falling down. Very similar situation. So what is happening with hail is that raindrops are being formed at a very high level in the atmosphere where the temperature is below freezing. So instead of rain drop being fallen as a water droplet, it forms a piece of ice. Now as this ice falls, it gathers together other bits of ice. It's called accretion. And when it falls, all of a sudden it meets more updrafts, which are caused by the warm temperatures, the hot day, air's rising, and it pushes this ice molecule up. So there's a force going on here where the ice molecule wants to fall down, but these updrafts are pushing it up. And as it pushes it up, it freezes again, it meets more moisture, it gets bigger and bigger. Now, meanwhile, on the surface of underneath, on the ground, nothing's happening because these hailstones are not falling as average size hailstones. They are being forced backwards, upwards and downwards, as many times. And this can happen 10 or 20 times. And each time that hailstone grows bigger and bigger and isn't falling to the ground. So the people on the ground don't notice anything. And then all of a sudden, the force or the weight of that ice particle or that hailstone is now too great and overcomes those updrafts, and then they plummet to the ground. And all of a sudden you get a massive hailstorm lasting 4, 5, even maybe 10 minutes when all these large hailstones suddenly plummet to the ground. And so it's exactly that there was a lack of rain and a lack of hail in the preceding half an hour or an hour. It's because these hailstones were busy getting bigger and bigger up in the atmosphere and then ultimately come down in a crescendo of extreme weather, if you like.
Well, thanks for explaining that. That makes it a lot clearer. Looking ahead, I want to ask what we can expect in terms of seeing in terms of extreme weather events in the future and how better we cope with that and with the effects of climate change, specifically in urbanized, high-density urbanized areas, to prevent the kind of flooding and damage impact we've seen over the past week.
Certainly, and one could easily just glibly saying it's all a matter of planning, but that's not as easy as it sounds. However, what has to happen is that town planners, looking at rivers, looking at spruits, looking at bridges, looking at culverts, all have to listen to the climatological forecasts and see whether or not they are taking advantage of that information. For example, when we say that rainfall is going to be more extreme, it means that a sudden shower may not be the same as it was 20, 30, 40 years ago, and the runoff capability of the infrastructure may not be enough to cope. So when we're building two things, when we're building new infrastructure, we have to say, right, we need to make those culverts bigger. We need to make the riparian zone, which is the zone next to the river where there shouldn't be any building or infrastructure, we need to make those bigger. But also we need to look at the area where the rain is falling that feeds into those rivers. And it's called hard standing in engineering terms. We put down a lot of tar and a lot of bricks. So the water doesn't have a chance to penetrate. There are no lawns. We're not saying that lawn is a fantastic idea, but vegetation and trees should always be planted where there are settlements so that the water can infiltrate into the soil, which does two things. Firstly, it feeds the vegetation, which is all great, and that vegetation then releases it and it goes back into the atmosphere. But secondly, it slows down the runoff. And we know that for sure, that the more vegetation there is, the slower the runoff is and the less likelihood there is of flooding. But we need to be careful that that vegetation isn't blocking the rivers. So we need to get the vegetation out of the rivers but onto the banks and into the areas where the water is landing during the rainstorm and flowing into that river. That will certainly make a difference. So when it comes to planning our infrastructure, we need to look at the physical built infrastructure, but we also need to look at the natural infrastructure in order to work with nature. So we're not going to say for sure that there's going to be more rainfall in Johannesburg and Pretoria in 20 years' time. We don't have that kind of certainty. But the kind of certainty we're getting right now is that when the rain does fall, it's likely to be more intense. There's more energy in the atmosphere because of increased temperature. There's no doubt about that. We've measured the increasing temperatures all over the world, including on the Highveld, including the Western Cape. We know that when the rain falls, it's likely to be more intense. That kind of information has to go into the planning. Now, it's very difficult to plan if you have unplanned settlements happening all over the place. We understand that. But as climatologists, we are saying, guys, you need to listen to this. And some municipalities have taken this to heart, and some municipalities have indeed done that. But of course they are constrained. They are constrained by money, and they are constrained by urbanization, where people are coming to live in cities, and the cities were not designed to cope with those sort of volumes.